Yeah, hi, this is Deepthi. This is our second component in applications of machine learning module. So in this, our component title is um, image classification using artificial neural networks on plant leaves dataset. So this is the code. So first thing, in this, we import essential libraries needed for building, training, evaluating, and visualizing our deep learning model. We use TensorFlow and Keras for model development, scikit-learn for performance matrices, matplotlib, and seaborn for the plotting and visualization. Our core dataset used in this project is the plant leaves dataset, which we load directly from the TensorFlow dataset API. So next, coming to this section, we'll load the dataset using TensorFlow dataset as TFDS. And after loading the dataset, we extract the class names from the dataset metadata using ds info is equals to these features. So in this sorry this features, so this will gives us the all possible label categories such as healthy, powdery, mildew, and rust. To get better understanding of the dataset balance, we iterate over training set dataset and count how many images belongs to the each class. Then we pre-process our data, like before feeding data into our model, we need to pre-process the raw images in the data set vary in size. So we define processing function that resizes each image to be a consistent 128 into 128 image. We normalize using pixel value range within 0 to 1 by divided by 250.0. This normalization helps the model convergence faster during training. So here we are using dot map method. Next, we batch the data into in the group of 32 dot batch size to improve training efficiency and enabling the prefetch, which allows the next batch to be prepared while current one is being processed. So next thing, we visualize our sample images from the dataset. For the better understanding of the nature of the data, we visualize the sample 16 pre-processed images from the training set. Each image is displayed using matplotlib along with corresponding class name as a title. This helps to verify that our pre-processing steps are working correctly or not. So here are the 16 sample dataset of the plant leaf dataset. So next we are building a CNN model. In this, within the data prepared, we construct a convolutional neural network using TensorFlow Keras sequential API. This model starts using input layer experts images of shape 128 into 128 into 3. Then we stack the convolutional three convolutional blocks, each consisting of convolutional 2D and max pooling. These layer extract hierarchical features from the input images such as edges, textures, and patterns, while progressively reducing the spatial dimensions. Then, after flattening the output convolutional layers, we used a dense layer with 128 units and ReLU function. They reduce the overfitting. We include a dropout layer that randomly disables 30% of neurons during training. Finally, the output layer uses a softmax activation to produce the class probabilities within the number of output units equal to the number of categories. After that, compiling, and next we compile the model. Once the model architecture is ready, we compile it using Adam optimizer. This is Adam the optimizer, which adjusts the learning rate during training for better convergence. The loss function is also used, uh, like sparse categorical cross entropy, which is appropriate when the target labels are integers rather than one hot encoder. This model is trained 50 approaches using the training dataset, which the dataset testing dataset used for validation after each approach. During training, Keras automatically tracks the loss and accuracy for both training and validation sets. So here, it trained each and every approach, like this 50 approaches, it's trained. Next, after training, we analyze how well model performance over time by plotting training and validation accuracy and loss. These plots help us to understand whether the model is improving and if it's overfitting or underfitting. For accuracy, we identify and annotate the each approach yield the high validation accuracy. For loss, we highlight the approach with the lowest validation loss. A small gap between training and validation matrices indicates good generalization also. So here, this is the accuracy graph, approach graph, and this is also graph. Okay, graph. After that, we model evaluate on the test data set. Once the training is completed, we evaluate the model performance on the test data set. We loop through each batch in the test set, make predictions using the trained model, and compare the predicted labels with the true labels. We then use the SCAT learn for the matrices to calculate performance indicators. Accuracy measures the overall correctness, and precision measures the predicted positives of actually correct. Recall, which assess how many actual positive were correctly identified, and the F1, which balances the precision and the recall. So here we got the accuracy like 0.88, precision 0.8843, recall 0.8823, and 0.8786 is the F1 score. Next, we go into the classification report to gain deeper insight into the model performance on by class basis. We generated detailed classification report. The report shown precision, recall, F1 score for each individual helps us to identify which class of the model struggles with. And also we have confusion matrix, which is a heat map, shows the relationship between actual and predicted labels. Values along the diagonal represents the, let's see here, like diagonal represents the predictions, while off diagonal indicates the misclassifications also. And the last, this to facilitate the further analysis and reporting, we can create also pandas that compares true and predictor labels for each test image. And this table includes both the class index and the human readable class names. So we print sample of first 20 rows of a quick look and to save the entire table. So, and to conclude this, I can say that the convolutional neural networks in image classification specially identify for plant diseases from leaf images. So in this, I can say that we cover every critical step from dataset loading, pre-processing and model training, and performance evaluation. So overall, I think this dataset demonstrates like a complete deep learning workflow and highlights how it's going to apply it for the agriculture for disease detection, like and crop monitoring, etc. So thank you.